Hello and welcome to another one of D's A to D videos. Today we're going to look at an example of bomb calorimetry in which we have a piece of metal that has an initial temperature of 85 degrees Celsius and it's placed in a styrofoam cup calorimeter that has the water initially at 25 degrees Celsius. After a while, they come to a temperature of 45 degrees Celsius. So what you should do at this point is write down all the important given information, like the mass of your surroundings. Determine what are your surroundings. What is your system? So let's look at that first. The metal block is my system. I don't know what metal it is, so I can't possibly look up its specific heat on a table anywhere. So the water has to be the surroundings. Now what we should do is write down the given information that's important. First, the system, which was the metal block, was at 85 degrees Celsius to start out with, and the water came to a final temperature of 45. That's given here and here. And you can calculate delta T. Delta T is always final minus initial. So if we do final minus initial, you get negative 40 degrees. And then if you look at the surroundings, which is the water in the calorimeter, the temperature was initially 25 degrees Celsius and then moved to 45 degrees Celsius. So if we want to calculate delta T there, you just do the difference between the two and you're going to get 20 degrees Celsius. All right? So, what's going to happen here? Let's kind of run through the steps. Well, the basic premise is always this. We are going to use the Q system first, which is the metal in this case. And since we don't know its specific heat, and at this point when I asked this first question didn't give you a mass, then I know that I can only calculate the heat capacity as is right now. The delta T I've already calculated as I just showed you. And what we're going to be doing is looking at the Q of the surroundings. Now I did give you the mass of the water. It's right here, the 45 grams of H2O. I do know the specific heat of water. You should know that. If not, you haven't been doing enough practice problems, because water is usually the one you use whenever you're dealing with these styrofoam cup calorimeters. The specific heat of water, if you were to look it up, and that is the amount of heat required to raise the temperature of 1 gram of your sample 1 degree Celsius. It's per gram. Same thing as heat capacity, but per gram. And that would be 4.18. So when you plug and chug, what does it look like? Alright, so the main premise here of all of these problems is going to be as follows. You're going to look at the Q of the system and set it equal to the Q of the surroundings with a negative sign in front. Alright? Again, we don't know the mass at the beginning of the problem of your metal sample, so we use C here on the left side times delta T of S, and then we use M H2O, specific heat of water, delta T. These are all given up there nice and neatly, so just plug in. If you do your work organized like this, it's hard to make mistakes. And what I recommend, instead of doing all this in one giant calculator step, go ahead and multiply the right side, see what you get. You should get this, and it should be joules. You should see that your terms on the right, in other words, degrees Celsius will cancel degrees Celsius, grams will cancel with grams. So then we're left with joules. And then after you get to this step, you need C by itself, so you need to divide both sides by that negative 40. You end up with your final answer of 94.05 joules per degree Celsius. So that's the heat capacity. Now there was a second part that asked you for the specific heat, So how do we get to specific heat from heat capacity? You guys should remember this equation. If you don't, learn it. The relationship between the two is that. Remember, specific heat is heat capacity per gram. So if you divide both sides by that gram right there, or the mass of your sample, you can get your specific heat. So 94.05 divided by 10 grams ends up with 9.4. All right, so I hope I've cleared up any confusion that you might have. Always just clearly label your stuff right off the bat. Figure out what your system is, figure out what your surroundings are. Then figure out what your initial temperature is and figure out what your final temperature is. After you do that, then calculate your delta T's, look up your specific heat or heat capacity that you need for your problem from your surroundings, in this case the water, and then just plug and chug. Okay? Again, this is the key part to this concept. Practice, practice, practice. Check out the advanced video. I hope this has clarified your confusion. Thank you and have a nice day.